the recording button. Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay, so today, eventually, we're going to go on to section 6.7. First of all, I have a question that somebody asked about. And this is number 27 from, I believe it was 6.6. And the question says, it says to factor, and here's the problem, x squared y squared minus 3xy minus 28. Well, we have two variables in this trinomial, but the coefficient up front is still a 1. So what we're going to do is we're going to break the x squared apart and the y squared apart. So we have xy up front, xy in the second factor, which will also give us xy in those middle two terms. So our product is negative 28 and our sum is negative 3. So how about 7 and negative 3? So plus 7 minus 3, that gives us, oh, wait a minute. That gives us plus 4. That's not right at all, is it? Oh, okay, let's go back and let's see what's going on there. Yeah, that gives us plus 28 or minus 28, but it gives us plus 4, doesn't it? Hold everything. Okay. Well, the biggest number has to be negative, doesn't it? So we've got negative 28 and 1, negative 14 and 2, negative 7 and 4. Oh, there we go. Yeah, 3 and 7 doesn't even, I don't know what I was thinking. Okay, so there's our two numbers, minus 7 plus 4. Okay. Any questions on that? All right. Do you have any other questions from section 6.6 before we continue on to 6.7? Okay. So here we go, 6.7. 6.7 is about the zero factor property, which works basically like this. If I have A times B equals 0, what could I say about A or B? Wouldn't at least one of them have to equal 0? To get a number times a number equal to 0, at least one of those two numbers has to be 0. So we'd say either A equals 0 or B equals 0, or both A and B equal 0. So if a number times a number equals 0, at least one of those two original numbers has to equal 0. Any questions about that idea? That's the basis of this whole section coming up. All right, so let's say we had this equation, x plus 2 times x plus 3 equals 0. Do you see that that equation is in the form A times B equals 0? So what we could do, if the quantity x plus 2 times the quantity x plus 3 equals 0, then we could say either x plus 2 equals 0 or x plus 3 equals 0, or in fact, they might both equal 0. Well, if x plus 2 equals 0, to solve that first degree equation, we would subtract 2 from both sides of the equation. If x plus 3 equals 0, to solve for x, we would subtract 3 from both sides of the equation. So now we've got these two solutions. Let's check them. Well, if x equals -2 and we put -2 in for x there, we'd have -2 plus 2, which is 0. And 0 times anything would equal 0. So that one checks. If we take x equals -3 and we put it in that factor, we get -3 plus 3, which is 0. And anything times 0 is 0. So that one checks. So for this equation, we have two solutions. Any questions about this problem? All right, let's take a look at another example. Let's say we have, let's see here, x minus 8 times x plus 8 equals 0. So again, it's in that form, a times b equals 0. So then we would take each factor that contains a variable and set that factor equal to 0. So we get x minus 8 equals 0 and x plus 8 equals 0. So we've got a product equal to 0. We're taking each factor of the product that contains a variable and setting that factor equal to 0. Well, let's see. X minus 8 equals 0. We'll add 8 to both sides of the equation, and we get x equals 8. X plus 8 equals 0. We'll subtract 8 from both sides of the equation, and we'll get x equals -8. So here we have two solutions to this equation. Any questions? All right, continuing on. Let's say we've got this equation, 5x times 5x plus 7 equals 0. So we've got the product of two factors equal to 0. So 5x equals 0, or 5x plus 7 equals 0. 5x is a factor. It doesn't have to have parentheses around it because there's only one term within that factor. Unlike the second factor, 5x plus 7, we need parentheses around that. Well, if 5x equals 0, dividing both sides by 5, we get x equals 0. If 5x plus 7 equals 0, solving for x, we would first of all subtract 7 from both sides of the equation, then divide by 5, so we get x equals -7/5. So x is 0, x is -7/5. If we take x as 0 and put it right there, 5 times 0 is 0. 0 times anything is 0, so that one checks. If we take -7/5 and put it right there, 5 times -7/5 is -7. -7 plus 7 is 0. Anything times 0 is 0. So that one checks. Okay. Let's see here. How about this one? N times n plus 1 times n minus 6 equals 0. So now we have three factors multiplied together equals 0. So if any one of those three factors that contain a variable equals 0, the whole thing will equal 0. So we're going to have three equations. N equals 0, n plus 1 equals 0, and n minus 6 equals 0. Any question about how I got three different equations?
No.
Okay. Yes, question?
No.
Okay, thanks. All right, if n equals 0, well, n equals 0. If n plus 1 equals 0, subtracting 1 from both sides, we get n equals -1. If n minus 6 equals 0, adding 6 to both sides, we get n equals 6. So we get three solutions to this equation because there were three factors that contained the variable n. Okay. Now, let's say we've got this equation, x squared plus 7x plus 6 equals 0. Well, that's not in the form of a times b equals 0, or maybe a times b times c equals 0. But we could take the left side of the equation using the factoring techniques we've been studying for the last week and a half and write it. Let's see, this would be plus 6 plus 1. Would that be right? X squared plus x plus 6x is plus 7x plus 6. Okay, so we're factoring the side that's not 0. So now we have a factor times a factor equals 0. So we'll take each factor that contains a variable, set it equal to 0, and then solve each of those first degree equations. So if x plus 6 equals 0, subtracting 6 from both sides, we get x equals negative 6. If x plus 1 equals 0, subtracting 1 from both sides, we get x equals negative 1. Let's check our solutions. Let's take this one and put it in up here. Let's see, we would get negative 6, the quantity squared, plus 7 times negative 6 plus 6 equals 0. Replacing each x with negative 6. Notice I have parentheses around the negative 6 so that when I square it, the negative is part of the base. Negative 6 times negative 6 is 36. And then minus 42 plus 6 equals 0. 42 minus 42 equals 0. 0 equals 0. So it checks. Let's go back and let's check this solution. That would be negative 1, the quantity squared, plus 7 times negative 1 plus 6 equals 0. Negative 1, the quantity squared, negative 1 times negative 1 is positive 1. Minus 7 plus 6 is 0. 7 minus 7 is 0. 0 equals 0. So again, the solution checks. This equation is a second degree equation, and it has 2 solutions. Alrighty, let's look at another one. A squared minus 17a plus 60 equals 0. This is very much like the last problem. We have a quantity equal to 0, but that quantity isn't written in factored form. So using the techniques we've been learning, we're going to get a and a product that is 60 and a sum that is negative 17. How about negative 20 and 3? Now, I'm not spending a lot of time going over how I came up with those numbers. That goes back to what we've been studying for the last few days. But needless to say, that's what we should come up with. If it's needless to say, why did I say it? I don't know. Anyway, so we get that. A minus 20 times a plus 3 equals 0. Oh, that's not correct, is it? It's not correct. Why not? It gives us negative 17, but it doesn't give us positive 60, does it? Oh, we've got to be very careful. So let's see. Yeah. It's got to be more than just one of those numbers. It's got to match both of them. Haste makes waste. Let's go back and think this through. A product that's positive has to have 2 positive or 2 negative factors. So I can't have one of each like I had. but the sum is negative, so it's got to both be negative. Let's see, negative 60 and negative 1, negative 30 and negative 2, negative 15 and negative 4. Oh, wow. Well, let's see.
Isn't it negative 12 and negative 5?
Yeah,
Negative 12 and negative
negative 5.
5. It sure is. Good job. I knew that you could speak. I knew if I waited long enough, someone would speak up. Good job. So there you go. So now we're going to get a minus 12, a minus 5. And that does give us the positive 60. But again, be very careful. Don't do like I did and just focus on one of those numbers, the sum. It's got to meet both conditions. Okay. So now a minus 12 equals 0. A minus 5 equals 0. Add 12 to both sides. A equals 12. Add 5 to both sides. A equals 5. And if we plug 12 in here and here, it should come out to 0. If we plug 5 in there and there and check it, it should come out to 0. Do you want me to check this one, or are you okay with it? No one has an opinion. Okay. Let's take a look at another situation. Let's say I've got x squared minus 36 equals 0. Well, I've still got a quantity equal to 0, but it's not a trinomial. It's a binomial. Oh, it's the difference of two squares, isn't it? X plus 6, x minus 6. So factoring it, setting it equal to 0, we get that. Taking each factor that contains a variable and setting it equal to 0, we get that. The first equation, I'll subtract 6 from both sides and get x is negative 6. The second equation, I'll add 6 to both sides and get x is positive 6. So I get two solutions. Let's see. How about this one? 16 z squared minus 25 equals 0. And again, if I'm going too fast, let me know. I can slow down or wait to go on to the next page. This is also the difference of two squares. Let's see. We're going to have 4z and then plus 5 minus 5 equals 0. So 4z plus 5 equals 0. 4z minus 5 equals 0. To solve the first equation, I will subtract 5 from both sides of the equation and then divide both sides by 4. So z equals negative 5/4. The second equation, I will add 5 to both sides of the equation and then divide both sides by 4, and I get z equals 5/4. So z equals negative 5/4 and z equals positive 5/4. Something to note, whenever we've got the difference of two squares like that, our two answers are going to be opposites of each other, one positive and one negative. That's going to happen. All right, let's go on. Let's say we've got x squared equals 5x. Well, this is an equation, but it's not set equal to 0. And it has to be set equal to 0 for this to work. For instance, if I say a times b equals 0, either a or b, one of those or both have to be 0. But what if I said a times b equals 10? Well, then there's an infinite number of possibilities. I could have 10 and 1, 5 and 2, 1/2 and 20, etc., etc. So it's got to be set equal to 0 for this whole process to work. So the first thing I'm going to do is subtract 5x from both sides to set it equal to 0. So x squared minus 5x equals 0. Now be careful, because x squared minus 5x looks kind of like the difference of two squares. It's a binomial. There's a subtraction sign in the middle, x squared up front, but 5x isn't a square. So you might be inclined to say, oh, it doesn't factor, there's no solution. But we've overlooked something. That is, the first thing we should do is take out the greatest common factor, which is just a plain old x. So it wasn't a difference of two squares, but we could take an x out. Now we're going to take each factor that contains a variable and set it equal to 0. So if x equals 0, then x equals 0. X minus 5 equals 0. Add 5 to both sides. X equals 5. Let's check our work on this one. Let's take x equals 0 and put it into that original equation. We'd have 0 squared equals 5 times 0. 0 equals 0, so that checks. Let's take 5 and put it in there. We'd have 5 squared equals 5 times 5. 25 equals 25. That one checks as well. Checks all around. Just like those government stimulus checks. Checks all around. Okay. Let's see here. Good to go on? Yeah? All right.
Yes.
Good. Let's say we've got 3x squared plus 14x equals -8. This is a second degree equation because of the 3x squared, but again, it's not set equal to 0. So the first thing I'm going to do is get everything on one side of the equation set equal to 0 on the other side. So I'm going to add 8 to both sides of the equation. And I'm also putting the left side in standard form, descending powers of the variable. Let's see if I can make a nicer looking 8 than that. Maybe, maybe not. Okay. I'm going to use factoring by grouping. If you want to use what is it, trial and check, let me know and I'll go back and do it that way. But A is 3, B is 14, C is 8, the product is 24, the sum is 14. How about 12 and 2? The product is 24, the sum is 14. So now I've got 3x squared plus 12x plus 2x plus 8 equals 0. Using factoring by grouping, the greatest common factor of the first two terms is 3x. The leftovers are x plus 4. So the leftovers are x plus 4 with a plus 2 outside, but that whole thing is equal to 0. Continuing, taking out the greatest common factor, x plus 4 times the leftovers, 3x plus 2 equals 0. So all that is to get it ready. Now I've got it factored, set equal to 0. Then we're going to take each factor that contains a variable and set it equal to 0. So if x plus 4 equals 0, we'll subtract 4 from both sides. X is -4. 3x plus 2 equals 0. We'll subtract 2 from both sides. 3x equals -2. Divide by 3, x equals -2/3. So my two solutions, x is -4 and x is -2/3. Okay. We good to go on?
Yes.
Yes.
Great. Here I've got 5m times 5m plus 8 equals -16. Now, at first, you might look at this and say, oh, this is going to be easy. The left-hand side is already factored. But there's a problem. Yes, it's factored, but it's not set equal to 0. And it has to be set equal to 0 for this thing to work, which means we're further away from home than we've ever been before. What we have to do, we're going to have to multiply this out, 25m squared plus 40m. I'm going to add 16 to both sides, 25m squared plus 40m plus 16 equals 0. Now that it's set equal to 0, I'm going to factor the left-hand side. But having it factored not set equal to 0 is not helpful. It takes all the more time to get to the right place. Well, let's see, 25m squared plus 40m plus 16. Oh, that looks like it might be a perfect square trinomial. Let's see if it is. We'd have 5m and 5m and 4 and 4 and plus and plus. Yep, that's going to give us plus 40m in the middle. So 5m plus 4 equals 0 and 5m plus 4 equals 0. So if 5m plus 4 equals 0, subtracting 4, we get 5m equals negative 4. Dividing by 5, we get m equals negative 4/5. Well, I'm going to get the same answer over here because I'm starting with the same equation. Now, you might say, so if it's the same answer, do we have to do both of them? Well, you do want to acknowledge that there's, let's see, the author calls it, it says it's repeated. So it says m equals negative 4/5 repeated, okay? That may not be significant now, but way down the road, when we start graphing these second degree equations, there'll be something special involved having those repeated solutions. But anyway, so m is negative 4/5 and m is negative 4/5. Okay, let's see here. Let's say we've got this situation, x cubed minus 7x squared plus 10x equals 0. So this is all set equal to 0 on the right side. That trinomial on the left, it's in descending powers. Oh, but there's a greatest common factor. Actually, wait, let's back up a bit. I want to point out that this is a third degree equation because the highest power of the exponent on a variable is a 3. Well, with our second degree equations, we've been getting 2 solutions. With a third degree equation, we're going to get 3 solutions. So the first thing I'm going to do is factor out the greatest common factor, which is an x. Okay. Then I'm going to factor further. That's going to be an x and an x. How about a minus 5 and a minus 2? Would that give us a product of 10 and a sum of negative 7? Okay. So we've got 3 factors containing a variable. So x equals 0, x minus 5 equals 0, and x minus 2 equals 0. So there's our 3 linear equations, our first degree equations. Well, if x equals 0, then x equals 0. X minus 5 equals 0. Add 5 to both sides of the equation. X equals 5. X minus 2 equals 0. Add 2 to both sides of the equation. X equals 2. So a third degree equation has 3 solutions. They may not all be unique solutions. Remember from the previous problem, we can have repeated solutions, but there will be 3 solutions. Okay, let's see here. How about this one? H times 3h minus 4 times h plus 1 equals 0. I want to talk about a common mistake that students make. This equation is already set equal to 0. That's good. And it's already factored. So all we have to do is take each factor, set it equal to 0, and solve it. What some students will do is they'll see that it's factored and they'll multiply it all together and then pull it all apart and get right back where they started, though sometimes they don't even do that. This is already good to go. It's set equal to 0 and it's factored. This is like some of the first problems we looked at. So take each factor, set it equal to 0, and solve those first degree equations. So if h is 0, there's one solution. 3h minus 4 equals 0. We'll add 4 to both sides. 3h equals 4. Divide both sides by 3. H equals 4/3. H plus 1 equals 0. Subtract 1 from both sides. H equals -1. Okay, let's see here. All righty, let's say we've got 10b cubed minus 15b squared minus 25b equals 0. Well, this is standard form of a second degree equation. That is ax squared plus bx plus c equals 0. The trinomial, let's see, it has a greatest common factor of 5b. So that would leave us with 2b squared minus 3b minus 5 equals 0. But now that trinomial that's inside, I've got to factor it. Again, I'm going to go ahead and use grouping. So a is 2, b is -3, c is -5, the product is -10, the sum is -3. How about -5 and 2? All right, so now I've got 5b, parentheses, 2b squared, minus 5b, plus 2b, minus 5 equals 0. So I'm using that grouping. I'm going to split the 4 terms in half. So I've got 5b. The greatest common factor of the 2b squared minus 5b is just b. And then 2b minus 5. So 2b minus 5 over here and a plus 1 outside. So now I've got 5b times 2b minus 5 times b plus 1 equals 0. All of that, to get it factored, set equal to 0. So now we're going to take each factor that contains a variable and set it equal to 0. So 5b equals 0. 2b minus 5 equals 0. B plus 1 equals 0. 5b equals 0. We'll divide both sides by 5 and we get b equals 0. So there's one solution. 2b minus 5 equals 0. We'll add 5 to both sides of the equation. 2b equals 5. Divide both sides by 2. B equals 5 halves. There's the second solution. B plus 1 equals 0. Subtract 1 from both sides. B equals -1. There's our third solution. So 3 solutions to a third degree equation. Okay, let's see. How about I wait a minute for you to get caught up? We good? Okay. Let's see here. Q squared minus 1/4 equals 0. Well, That is the difference of two squares, because we could write it as q squared minus, what times itself is 1/4? 1/2. 1/2 times 1/2 is 1/4. Okay, so this is going to be q plus 1/2 times q minus 1/2 equals 0. So we'll take each factor that contains a variable, set it equal to 0. So q plus 1/2 equals 0. Q minus 1/2 equals 0. Q plus 1/2 equals 0. We'll subtract a half from both sides and we get q equals negative 1/2. Q minus a half equals 0. We'll add 1/2 to both sides and we get q equals positive 1/2. So two solutions to a second degree equation. Okay, let's see here. Let's do this. Okay, now we're going to do, this is problem A, and then we're going to do problem B. Problem A says 12n squared minus 5n minus 2. 12, let's see, B is 12n squared minus 5n minus 2 equals 0. Now, the problem part A is not an equation. We cannot solve it. We can factor it, but we can't solve it. Let's see. A is 12, B is negative 5, C is negative 8, the product is negative 24, the sum is negative 5. How about negative 8 and 3? So we get 12n squared minus 8n plus 3n minus 2. Okay. We're going to split it down the middle and we're going to get 4n, 3n minus 2, 3n minus 2 and a plus 1. So we get 3n minus 2 times 4n plus 1. And that's as far as we can go with that problem. We just had a trinomial. Okay, now part B, we have that same trinomial set equal to 0. So it would factor into the same two factors, but that's equal to 0. So I can take it further and solve it. So then we're going to add 2 and we're going to get 3n equals 2. Divide by 3, n is 2/3. 4n plus 1 is 0. Add or subtract 1. 4n is negative 1. Divide by 4, n equals negative 1/4. So this second degree equation has two solutions. This trinomial can factor into two factors, but we can't solve it because it's not an equation. So be careful with that. All right, because what I'll have people do on a test, they'll take an expression and they'll just turn it into an equation, set it equal to 0 and solve it, or they'll take an equation and they'll forget to solve it. They'll just factor it and stop there. So be careful with that. All right, well, that's all I've got for you today. So tonight you've got 6.7. I'll be back at 1:15 for an office hour. Should you have need of me, we'll